In example 1, we're going to go through understanding the inverse sine function. A function has an inverse if and only if it is 1 to 1, meaning that each y value of the function can be matched with no more than one x value. Is the sine function to the right 1 to 1? So if we take a look at this sine function, if it's 1 to 1, we can use what we call the horizontal line test. So this red line is what we call the horizontal line test, and if you move that red line up and down the function, if it touches in more than one spot, that tells us that this function is not 1 to 1, which means that this is not. So we could say the answer here is no, because it fails the horizontal line test. If, however, we restrict the domain of the sine function to just the interval from negative pi over 2 to positive pi over 2, the restricted function is 1 to 1 and takes on all possible range values, so every number from negative 1 to positive 1 of the unrestricted function. It is on this restricted domain that y equals sine x has an inverse function called the inverse sine function, and it's notated as y equals the sine raised to the negative 1 of x. The graph of the inverse sine function is found by reflecting the graph of the restricted sine function in the line y equals x. So if you take a look at this right here, we are going from, here's negative pi over 2, where this dotted line is, to positive pi over 2. So we are just looking at this part of our sine function. So that part of our sine function takes on every number in our y values. So it goes all the way from negative 1 and all the way up to positive 1. But this function, just using the horizontal line test, which means we're going this direction, is 1 to 1, which means that horizontal line only touches this part of our graph at one point, just this red part that I highlighted here. The inverse sine function tells us that we are just reflecting it over the line y equals x, which basically tells us we are just switching the x and the y to find that inverse. So coming down here, what is the domain of our inverse of x? Our domain of our inverse function is going to be the same as the range of our original sine function, which is from negative 1 to positive 1, including both. And then what is the range of our inverse sine function? Well, our range of our inverse is going to be the same as our domain of our regular one, and that domain is the one that we're looking from negative pi over 2 to positive pi over 2. So our range is from negative pi over 2 to positive pi over 2 for our inverse function. Because the angles and arcs given on the unit circle have equivalent radian measures, the inverse sine function is sometimes referred to as the arc sine function, y equals arc sine of x. So the inverse function and the arc sine function are the same if and only if the sine of y is equal to x when x goes between negative 1 and positive 1, and our y goes between negative pi over 2 and positive pi over 2. The sine inverse or the arc sine can be interpreted as the angle or arc between negative pi over 2 and pi over 2 with a sine of x. For example, the sine inverse of 0.5 is the angle with the sine of 0.5. Moving to the box below, recall that sine of t is the y-coordinate of the point on the unit circle, corresponding to the angle or arc length t. Because the range of the inverse sine function is restricted to negative pi over 2 to pi over 2, the possible angle measures of the sine or of the inverse sine function are located on the right half of the unit circle. So we are looking at y equals sine inverse of x. So if x is greater than 0, then our y value is going to lie in quadrant 1 between, this is just this is just an abbreviation for between 0 and pi over 2. So this is quadrant 1 right here. So if our sine or inverse sine is positive, again, x is greater than 0, we are going to be lying in this first quadrant. And if you think about, we're going to be doing this mostly with our special right triangles. So that means that we're going to have answers of pi over 6, pi over 3, and pi over 4 in that first quadrant. Now, if x is less than 0, then our y value is going to be in the fourth quadrant, which is between negative pi over 2 and 0. So the fourth quadrant is here, and we are restricted between negative pi over 2 and positive pi over 2. So if we think about our special angles in the fourth quadrant that we're looking at negative pi over 3, negative pi over 4, and negative pi over 6. If you have questions, let me know. Otherwise, we'll kind of touch on this a little bit more when we get to example 2.